So welcome to Medialab Academy Professional Technologist Talk Series 8 2021. So this is a final series of this year. So this program is a part of a continuous professional development CPD program for technologies and inviting speakers from academic industry for knowledge sharing purpose. So with organizing partner, Malaysia Research and Education Foundation, MyRef. And on behalf of Medialab Academy and Working Committee, we would like to thanks to all participants for participating and to be together with this talk today. So for your info, Medialab Academy is an entity of Medialab Alliance yang Berhad. It's Technology Expert Panel, our TEP, with National Board of Technologies, MBOT, under Telecommunication and Broadcasting Technology field, so under TB. So for today, we would like to welcome our speaker, IRTS Dr. Muhammad Fauzi bin Abdul Rahman. Assalamualaikum, Dr. Fauzi.
Waalaikumsalam.
So, Dr. Fauzi is a senior lecturer and he also head of Department of Electronics and Computer Engineering Technology. So, Fakulti Teknologi Kejuruteraan Elektrik and Elektronik, FTKEE, Kampus Teknologi, Universiti Teknikal Malaysia Melaka, UTEM. And he's specialized in energy harvesting and photonic research. So, a brief about Dr. Fauzi. So before joining UTEM in 2009, he started his career in 2001 as electronic engineer with Panasonic Manufacturing Malaysia. And then he joined Toyota Boshoku UFW Sdn Bhd, TBU, as a senior engineer. So he developed spare parts and assembly parts for Toyota cars such as Vios, Corolla, Camry, Innova, Fortuner. And he also developed a few products. And then in academics, he obtained his degree electronic engineering in 2001 from Tokai University, Japan. And in 2011, he obtained master degree in electronic engineering and electronic system from UTEM with final year project titled Investigation of Useful Ambient Vibration Sources of Energy Harvesting. And in 2016, he further studied in photonics and obtained PhD in 2019. From University of Malaya. His PhD thesis is about generating pulse fiber laser, particularly a short length saturatable absorber using a passive approach. Part of that, Dr. Fauzi is also a member of IEM, a high community member of the Optical Society of Malaysia, OSM, and he's a registered professional engineer with Board of Engineers Malaysia and professional technologies with National Board of Technologies. So for today, the table is basically about the fiber optic technology in telecommunication, which the topic is a generating pulse fiber laser based on passive technique. Without further delay, please to invite Dr. Fauzi to present his topic. Silakan, Doktor.
Alhamdulillah, terima kasih TS Azhar mewakili Medialab Academy dan MyRef. Okay, pada hari ini saya sungguh like to thank to those organizers for inviting me for this briefing and speak about my research, recent research in the generating of pulse fiber laser using passive techniques. So let me go through to the slide. Okay, thank you participants for joining this talk. Okay, without further ado, okay, let me have a speak on this generating pulse fiber laser based on the passive techniques. Okay, can you all see this slide? I hope.
Boleh.
Okay, thank you. Okay, the topics outlined for today's briefing will be first a bit study on the background and then we'll followed by the research objective, then methodology in obtaining the saturable absorbers as one of the method for generating pulse laser based on passive techniques. And then we'll go to the main results, and we'll talk about novelty and contributions with the possible applications and the future directions of this research. Okay, let's go to the concepts of pulse laser. Okay, this is the difference between continuous wave and pulse laser. As the continuous wave works in a average power mode, while this one, okay, will work as a pulse laser with a high peak power. Of course, the repetition rates will be in kilohertz to megahertz. Okay, okay, how we do this is we just sandwich or place in between of these two fiber, the fiber-based SA or any SA materials. Okay, we'll look into that later. Okay, by inserting this, as I mentioned earlier, we can generate from the continuous wave into the pulse laser. Okay, the pulse laser has many benefits. So the benefits will be talked at the last sessions. I will brief a bit about the applications pertaining to this pulse laser. So in kilohertz, normally we call it as a Q switch when it operates in high frequency, which is in megahertz. So this one refers to the mod lock operations. Okay, what is the main difference based on the literature review perspective between the Q switching and the mod lock? Okay, Q switching happens when the gain is highest compared to the loss. Okay, we have a loss, then we have a gain. Okay, after a certain periods of time, it will develop the output pulse with higher peak power. Okay, what is the mod locking? Mod locking, of course, in the fiber, okay, we have several frequencies. Okay, several frequencies, and then superpositions between modes. If this one is lined together, okay, at this point we'll have a very high intense of peak power. Okay, these two can be done by sandwiching saturable absorbers, as I mentioned earlier, between two fiber connectors. Okay, the research significance of using the short pass fiber lasers compared to the long pass or continuous wave. As you can see that when using the long pass, okay, we'll have surface damage, okay, between the holes or surrounding the holes. I mean, okay, where when we use the short pass, we can see that the holes produce a very nice one without lots of damage. How that one is possible? Because of no micro cracking, no melt, or no hot dance, and no heat transfer surrounding to the materials. So this is the wavelengths. Okay, the wavelengths of the electromagnetics. But for our research, we basically focusing on 1 micron up to 1.55 and up to 2 micron. There will be three possible regions right now in our faculties that we are focusing into. Okay, beyond that, of course, we need more resources, such as measuring devices, and certain laser mediums in order to correct added regions. Okay, how laser works? Okay, let's look into one of the short videos how laser is work. Okay. 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 Let's discuss about the how the lasers work. Okay, how laser works. So basically, a basic laser like this ruby laser consists of a rod, okay, made of a ruby crystal. So there's a rod inside, and with a mirror on each end and a flash tube. There is a mirror in between, and there is a flash tube. Okay, a burst of light. Okay, a burst of light from this one, from the flash tubes, adds energy inside the rod. Okay, will give energies into the roots and excite the ruby atoms, okay, and produce light particles called photons. When it absorbs lights with certain wavelengths, okay, it will also create photons. The photons strike the atoms, okay. One photons strike the other photons, the other atoms, and it will create more photons, okay, bouncing back and forth between the mirror within the rods. Okay, the photons will bounce back and forth and back. Then the number of photons becomes so great, okay, that they pass through one of the mirror. This one is partial reflections. This one is fully reflective. This one is partial reflections with maybe 95% reflected, and only 5% is allowed to leave this room. And the laser beam is emerged. Okay. Okay. This one, a briefing about illustrations about what how it works. One atom absorbs, and then this will the electrons will get the energies and jump into another states of levels. And then when it want to go back to its ground level, it will emit photons. Okay? And then these photons, when excite another atoms, okay, it will create two photons comes out. Okay, this one laser beam, laser beam. Okay, you can see the laser beam inside the waveguide or in the fiber. And this one, energy from light excites electrons in atoms of optical materials, and then move to a higher energy orbit. Okay, this one explaining this one, and this one is the applications. Okay, we can see that laser with high energy can make this one fire. Okay, let's look into the differences between fiber laser and solid state laser. Solid state laser is using bulky parts. Okay, we'll talk about that one later. Fiber laser normally using a fiber, silica glass fibers, and doped with ytterbium, or either can be erbium or thulium. Okay, advantage of using the fiber laser as compared to the solid state lasers, of course, it will give high powers, ease of cooling in long fiber. Okay, because fibers normally is designed to have a high surface areas, okay, and long length. And of course, because of that, it will give the advantage of ease of cooling and high stability, because we can splice the wave guiding fibers, okay, without losing too much on the power. And then it has a high reliability, operates at 24 hours for 7 days, even for decades. And lower total cost of ownerships, okay, easy to maintain, then low jitter and low amplitude noises, compact form factor, the fiber is very flexible, and then can be compactly wrapped up or compactly located in one case, then easy to operate and immune to tough environmental changes, because it has like jacket protecting the light inside, so it will not get immune to environmental changes. This one normally is in free space. We'll look into that later. Okay, there's also some disadvantage, but we can see that there are more advantage as compared to the disadvantage. Okay, this one is fiber laser, while this one is a bulk laser or solid state laser. This one running in a free space. Okay, where the lasers, okay, got into the mirror and then maybe got reflected. Okay, in this case, in the case like this, so we have lots of mirrors on, and the problem with this is because of the maintenance. When this one is attached with a device that vibrates, of course there'll be a dislocations of parts, and we have to maintain this one by securely put it in the firm locations, or relocate it at a original designated positions. Or this one fiber laser, okay, okay, like this, we can, because of its fiber, we can make it compact, and there'll be no issues on moving the device around. Okay, we'll talk about the research motivations. Conventional methods, we use CSEMs. CSEM is a semiconductor saturable absorbers mirrors. This one is quite bulky, and then there'll be lots of alternative to that. One way is by using the film-based saturable absorbers, whereby we have to fabricate this one. Okay, I'll show it to you. Okay, on how we develop this one. Then using the bulk material SA. Okay, this one can be done using silicon tips, using mechanical exfoliation technique, and then based on the liquid base. Then how we do that? Okay, we take only a piece of this one, a tiny piece of this one, and then we just put at the at this stage, and then these fiber connectors are put together or deposited on a fiber connector and facet. Or we can just put the thin layer of films, okay, just put like this one into one of the fiber connected facet. Or we can put on a tapered fiber. Tapered fiber means that there's a fiber and then we use sandpaper, okay, and a wrap on a wheel, okay, that can be rotated, and then it will move certain parts, okay, and it will create evanescent fields. And when we put, we can put this one by putting a liquid droplets, okay, onto this. We can also integrate saturable absorbers into the fiber laser cavity. Okay, this one is it's like this one. It's like this one. This one is using the rotating sandpaper. This one maybe, so yeah, this one using, this is fiber. We move the jackets or the protecting, and then leaving the core and the claddings, and then there'll be a burner, and then it will rotate. Okay, this one is, and then there'll be a forcer to force pushing to the other directions to make this one very small in width. Okay, we call it width. So this one is a core, while this one considered as a cladding. So that's other techniques, and then maybe we can also use a fiber-based SA. Okay, this one is what I have done in my research study during my years in Universiti Malaya. Okay, of course the fiber SA is it can be a thulium, short fiber length. Okay, dope with a thulium. Of course, there'll be a thulium ion dopants inside. Okay, with a length of only maybe 5 cms. And then this one, of course, we can connect to fiber connector. This one also fiber connector. So integrate this one into the cavity so that it can become a passive technique to generate fiber pass laser. Okay, let's talk about passive versus active techniques. Okay, what is the saturable absorbers? Saturable absorbers, we can simply see as a switch that can turn on and off. But passive means it use no electricity or no energy. By itself, it can turn on and off. While this one active technique, we must provide energies so in order to operate. While this one is so bulky, and expensive. Okay, just now we have average continuous wave. Okay, how to convert into pulse laser? We need a loss modulator. Loss modulator which behave like a switch. Okay, that can turn on and off. Okay, so that we can have high peak power of lasers. Okay, but if we integrate this one, it requires cost, which is quite expensive and bulky, like this one. And then it also works at certain wavelengths. What is the benefits of using passive techniques? Okay, this one we can make it into films, which is very small as compared to this one, very light, and then cost efficient. And furthermore, this one have a long or wide bandwidth, wide operating bandwidth. So it means that certain materials may behave like or may have a characteristics to work at 1 micron, 1.55 micron, as well as 2 micron. While this one, okay, it only works at certain wavelength. Okay, this is the summary of the real SA versus artificial SA. Okay, passive techniques have two types. One is real, one is artificial. Okay, we'll look into the differences between real and artificials. Okay, real SA, such as semiconductor settled absorbers mirrors, okay, or low dimensional nanomaterials, which use material themselves possess light intensity dependent nonlinear absorptions to achieve SA effects. So the SA must have nonlinear absorptions, okay, which we'll discuss afterwards. Okay, so this one using real material, but what is this one? This one is using artificial without real materials. We use some kinds of techniques like nonlinear polarizations evolutions. Okay, there's no materials, but it can generate or it can behave like having a nonlinear absorptions in the cavity. And then there are more, such as nonlinear optical loops mirror, and then nonlinear applications loops mirrors. Okay, which use the nonlinear effect. Okay, just imitate the behavior of a real SA to produce nonlinear absorptions. Okay, this one talking about system. Okay, system is one of the category falls under real SA. Okay, system is quite famous in the early 1990s something. Okay, the main researcher or contributor for this one is Ursula Keller. Okay. But system, of course, is compact. Okay, it's quite bulky as well, and still cost expensive as compared to the real SA that we going to introduce afterwards. Okay, where the systems be put inside the laser systems in order to produce pulse laser. Okay, you can see that system is put here, so there'll be lots of devices, lots of optical devices inside. Okay, system offers only narrow operating bandwidth. Okay, it has a disadvantage also. That's how researchers are looking into alternative SAs, which are more cost efficient and then have a wide operating bandwidth and then have low maybe damage thresholds and so on. And it evolves into 2D nanomaterials. Okay, so 2D nanomaterials that consist of black phosphorus, TMDs, graphenes, antimony, MagZine, bismuth, and topology insulators. Okay, there are three famous, quite common techniques which can be found in the literature. The first one is mechanical exfoliations, whereas we have a bulky material like graphene or black phosphorus, okay, using silicon tips. Okay, it can, when we remove the silicon tips from this one, we can have several layers. Okay, like this one, graphene, we have many layers, that have a very weak van der Waals force, which can exfoliate it by using only sticky tape. In this one, we just take only a part of those and then put into the fiber laser cavity. And there's a technique called liquid phase exfoliations as well. Okay, like this one. Okay, have several layers and then disperse into solvents. Okay, and then we do ultrasonications, and after that we go for ultracentrifugations, so that we can have a dispersed solutions which can be used later to form into maybe film. Okay, put into a petri dish and then leave for a few days so that we can peel off these very thin layers and use only maybe 1 mm time 1 mm, the square area of that film to be used in our fiber laser cavity. And then there's also a technique called chemical vapor depositions, where we use gases. Then this gas, okay, two kind of gas interact each others, and then it will react chemically, leaving only the M, okay, sitting or leaving on the substrates. Okay, these are the objective. First, fabrications, and then investigations of the characterizations using certain characterizations devices such as DX, VSense, and balanced twin detector, and then demonstrates the novelty and the performance. Okay, for example, this one is using on how we fabricate the saturable absorbers. Okay, one of the technique that we use is electron beam thermal depositions. Okay, there is devices in Universiti Malaya. Okay, where we just put a metal. Okay, a metal, and then there'll be a PVA film. PVA film we have to fabricate earlier, and then the metal will vaporize and then stick onto the PVL films, and we can have this kind of a film. Okay, this one is titanium. Okay, one of my colleagues did this titanium, and then we have gold and then copper. And then we do the characterizations. Okay, this one, the FISEN. So we send the samples to the lab to test the nanoscopic views using FISEN. And then here is EDX. Okay, the purpose of EDX is to confirm that in that materials we have titanium as what we claim. So of course this one is because of the PVA, polyvinyl alcohol film. So just now this one is a PVA, and then this one is the several layers of titanium. Okay, and these two elements creates what we have here: carbon, oxygens, and titaniums. What normally people want to see is what we claim that we have fabricated, like titanium. So we must show that the titanium exists in the results. Then we also did linear absorptions. Okay, just now the saturable absorbers must, in order to operate at that regions, for example, if we want to make use of these saturable absorbers at 1 micron, so meaning that it must have certain absorptions. Like this one is about, at this 1 micron is about 3.1 or 3.2 dB. So dB shows that there's some absorptions that can be used to make this one as a loss modulator. Okay, turning on off so that we can have pulse laser in the fiber cavity. And then like this one, it also shows a quite good absorptions. Okay, at 1.5 and 2 micron. Okay, for it to work as a saturable absorbers, it doesn't necessary to have very big absorptions. You only need just a small absorptions so that it can work efficiently. And then this one is a nonlinear absorptions. Okay, why we call it as a nonlinear? Because the graph itself is a nonlinear. Okay, before reaching the saturating point. So the saturable absorptions, okay, normally will count from here to here. Okay. This one for gold. This one for copper. Okay. This one shows the fabrications of film saturable absorbers. Okay, like this one we use titanium oxide powder and then put into SDS, and then becomes TIO solutions. This one we stirred for 5 minutes and then followed with a centrifugations process. Then we'll get okay, two kind of layers, two kinds of solutions. Supernatant containing TIO solutions. Then latest stage.
Kami ni plannya nak laut tahu.
Sorry. Okay, I'll continue.
Okay, sila continue. Maybe siapa yang ni boleh off mic ke? Peserta yang lain? Sementara speaker bercakap. Terima kasih.
Okay, and then we mix together with the PVA solutions, and after that we centrifuge, and then put some droplets into a petri dish, and then leave for a few days to dry, and then we peel off, and then you'll get this kind of TIO films. Okay, this one using instead of using titanium oxide, this one is using holmium. Okay. And then this one is a characteristic done for the fiber-based saturable absorbers. Just now we mentioned about from metal, then this one from powder, this also from powder to make solutions. So this one is a fiber-based saturable absorbers. Just we cut a short piece of a fiber doped with a, for example, TiO, titanium oxides. This one latest from my colleague, okay, using coffee, spent coffee, maksudnya used coffee, and then we do the filtering works, keep this in ovens, then crush the spent coffee ground, this one, then mix with isopropyl alcohol, stir and mixture. Then we proceed with the centrifugation, centrifuge. Then do the filtering works. Then this one, we get this one, and then we mix with the PVA solutions. And then, of course, like the previous method, we leave for a few days, and then we peel off to get the coffee ground in the PVA filament. Okay, this one is the characteristics. Of course, when want to publish, we have to have certain characteristics analyzations. This one, like we mentioned earlier, FSAM. And then this one, nonlinear absorptions, and this one is linear absorptions. And then this one, just to know that we have elements of coffee inside, but of course this one in chemical formulas. And then this one is the results. We get a pulse laser. Okay, pulse laser. Okay. This one we have run few tests. We have tested at different time. So we have 3 readings. We just put there in order to show that it has a quite nice pulse. And then this one is a repetition rates. Of course, for Q switchings or Mohd locks, normally Q switching, it has a pulse width that varies when we varies the pump power. Of course, the pulse width also. What is the pulse width? Okay, pulse width is this one is the pulse width. Okay, measured at the center. Okay, full width half maximum. This one is the pulse width, and then the output power, the pulse energy, as compared to the pump power. When we increase the pump power from the threshold, okay, up to the maximum. Okay, this one is the output power output power, this one refer to here, while this one is referred to the past energy. Okay, let's look into the experimental setup. Okay, this one is the experimental setup. We have a laser pump, laser diode pumps. Of course, this one operating at, let's say, 780 micrometer. Okay, this one is entered through the wavelength division multiplexer. And then this one is the gain medium. Okay, gain medium, fiber, dope with either ytterbium, erbium, or thulium. This one is the dopant. So maybe around 5 meter, or in certain case 2 meter. Depends on the optimized length. Then output coupler which the output can be split into two. Maybe this one it only takes 10%, while leaving 90% to be circulate inside the cavity. We call it this one cavity, to build up the laser. And then we only takes 10% for the measurement purpose. This one may be using optical spectrum analyzer. We can also switch to oscilloscope or switch into RF spectrometers to see the performance of the pulse laser. Okay, this one is the saturable absorbers. Okay, we just put here. Okay, just put a tiny piece of the film saturable absorbers, for example. Then we tightly capsule it, and then we pump this laser pump. Okay, so that it will excite the gain mediums. Okay, without having this, of course the laser will be continuous, but after putting this one with the correct saturable absorbers, will get highly intense peak power, which we call it as a pulse laser. Okay, this one is the optical spectrum trace. Okay, when using the optical spectrum analyzers, this one is the pulse laser, which we see using the oscilloscope. Okay, I'll speed up this thing. Okay, this one is the results. This one is the RFSA. RFSA trace, radio frequency spectrum analyzer. Okay, this one. This one shows the first harmonic, or we call it not the first harmonic. We call it the first fundamental frequency. So the signal to noise ratio is taken from this one up to here. The highest better. And then results for mode lock. Okay, this one, the mode lock pulse trains. Okay, this one you call it a pulse train, so like a train. Okay, with different pump powers. Okay, the mode lock normally will have the same repetition rates. Okay, although the pump power is vary. Okay, so that's one of the characteristic which is differ from the switch. Okay, this one is to show the wavelength stability. Okay, I'll just speed up this thing. Okay, this one, the experimental setup. Okay, we're using the fiber-based SA. This one using fiber-based SA. Okay, conventional method, maybe we use film SA. Okay, or maybe we can switch between using fiber SA or film SA. This one is the result, same as previous one. So this one is the result summary for TIO. Okay, 1 micron, 1.5, 2 micron, 1.55, 2 micron. Okay, this one is from the literature. So there are so many types of materials, and so that the researchers surrounding us keep demonstrating, which implies to us that this research is still receiving quite demanding or high demanding rate. This one is for 1.5, okay, for 2 micron, okay, using many kinds of fabrication methods. Okay, this one is the applications. Okay, as you can see that we can put the pulse lasers, the cavities inside this case, tiny case. Okay, this one is for tattoo remover. Okay. Okay, this one is face treatment using lasers, using pulse lasers. So before, so tattoo. This is show. Okay, then it can be used as a LiDAR, remote sensings, okay, capturing informations by transmitting lasers and then get the feedbacks. Okay, scan the ground and measure the range by using this measurement. The shape contour of the ground from the air can be measured. And then by using 2 micron pulse laser, LASIK surgery. Okay, 2 microns radiations have coagulations. Coagulations means bleeding separations during the surgery. Can help reduce the coagulations. And ISIF because of class laser, because of the ISIF class laser botulium with high water absorptions, which give minimal penetrations depth into human tissues, so it will not damage the human tissue very much. And then future work directions, we can think of like heterostructures of combining two cytobabsorbers like graphene, black phosphorus, or maybe improve the saturable absorbers parameters for ultra short pulse, then combine the artificial and the real SA together, or maybe using the multi-mode fiber lasers, okay, in order to get high energy, and then maybe can proceed with the research beyond the 2 micron, 2.4, although we might have a challenge in terms of measurement device and the laser mediums. Okay, in conclusions, we have demonstrated, okay, what we have fabricated for alternative SA, and then the SA also has been characterized, okay, using nonlinear optical measurements, linear absorptions, FSAM, EDX, and then the output for analyzations in comparisons with 1 micron, 1.55, and 2 micron also has been demonstrated. Okay, I think that's all. Okay, this is the some of the equations that might be related to the research in the field of pulse fiber laser. Okay, I think that's all. Thank you. I will give back to TS Azhar for question and answer sessions, I think, maybe. Okay, thank you.
Okay, thank you, Dr. Fauzi, for the good talk and knowledge sharings about fiber laser. So next, I think we'd like to open for Q&A to the floor, and any questions. So maybe you have a few questions on the chat box, Dr. Fauzi.
Oh, okay.
So maybe participant also, I mean, if you have any questions, you can ask direct to the floor, or you can put in the chat box. So there's questions. First, fiber laser passive technique. Is it any commercialized use of the applications? And then about the using laser, is it affecting our skin, health? And the third one is any industrial standard developed for this fiber laser, maybe in Malaysia.
Okay, this one, how to make sure that laser, this one, not affecting our health or skin. Okay, basically lasers ni ada dah banyak products, commercialized product, which shows a good results. For example, in LASIK, okay, has been used for years maybe, okay, and have shown great results compared to the conventional type of method using a knife or something. So that can surely, okay, attract consumers. Okay, I also have done LASIK surgery previously, back in 2013, I think. Okay, and quite good. The result is quite good. And for tattoo removal, for example, it's hard to use other kinds of method like surgery, conventional surgery, but it's I think it's more easier using the tattoo removal laser surgery. And then for face treatment, like I showed just now, in Korea basically, there are numbers of companies or skin fair treatments that offers great kinds of machines to support for this demand. So I think laser has good benefits and can give more good results compared to others now, if you use in a proper technique. Okay, ada lagi ke?
About the industry standard developed, any industrial standard that developed locally for this kind of laser applications, especially on the health side?
Saya rasa ada lah. Tapi yang ni saya tak saya boleh show kemudian lah. Yang ni saya tak dapat jawab sekarang. Saya rasa ada.
Oh, okay. Okay, anybody else? Any questions? So, announcement also to participants. Please make sure that you all register in the attendance link. But because we're going to issue certificate based on the attendance lah. I mean, whoever registered but not coming and also fill up the attendance, I think we consider not fulfill the 1 hour CPD point. So it's quite essential for you guys to fill up the attendance. Any issue, you can also contact our committee lah, from the email link. So okay.
Yang Dr.
Ada sesuatu?
Fiber laser with passive technique ni dah commercialize ke belum kan?
I tanya about the commercial. Ya, betul.
Yang this one kalau kita tengok there are numbers of patents lah. Okay, and I believe there are growing numbers of companies lah yang buat benda ni. Like just now the Ursula Keller, dia pun dah buka satu company. Okay, tapi dia promoting systems lah. Because systems ni kalau in case of thermal damage threshold dia agak okay as compared to film. Tapi yang saya cakap tadi contohnya macam using fiber based cyclable absorbers tu quite good lah untuk tahan thermal damage threshold. And then of course dekat luar sana, dekat China contohnya, ada banyak company kalau kita tengok yang promoting this kind of technique as compared to the active. Okay, itu saja kot.
Ada one more question, Dr. Fauzi from EDZ Jambros. It's about Assalamualaikum Doctor, laser usage in widely used commercially. So for I did remember that Malaysia Nuclear Agency is trying to govern and act or having a laser safety officer to see certificate. So maybe dia tanyalah, you have input on this about the laser safety officer LSO under agensi nuklear.
Okay. Yang ni saya tak berapa aware lah. Tapi maybe saya boleh carikan. InsyaAllah next time. Saya rasa ada tu.
So, okay. By the way, kalau whoever nak contact Dr. Fauzi to ask more questions in future or to do some collaborations on fiber laser dan bidang-bidang berkaitan, I mean you can contact direct to Dr. Fauzi lah. So, later we will share this slide and also information through email lah after finish this program. So you can tengok balik recording and then maybe you can share also the slide, Doctor. If possible. Yeah. So to everybody lah. So okay, since we are at the end of the talk now, so dah pukul 12. So we would like to thanks to all participants, organisasi partner, advisor from UTM, Dr. Ranjit, Aira Anwar, Dr. Aisyah, Dr. Nick, and our friend from MyRef, TS Karudin, and also Dr. Hidayah for supporting Medialab Academy Professional Talk. And from series 1 until series 8 this year lah. So this is a final talk lah, Doctor. By the way, is the final talk of the year, tahun 2021. So insyaAllah we may continue this program next year lah. Selain itu, kami ingin mengucapkan takziah jugalah kepada sahabat-sahabat kita yang terjejas kerana bencana banjir yang berlaku pada masa kini. So semoga dipermudahkan segala urusan. Amin. Dan itulah seterusnya yang terakhir kita nak sesi bergambar lah, nak persilakan semua peserta yang hadir untuk buka kamera dan kita nak minta Dr. Hidayah lah tolong ambil gambar, Dr.
Ya, boleh. Maybe Dr. Fauzi can unshare. Okay, dah unshare.
Dan share. Okay.
Okay.
Bagi masa sikit nak buka.
Ya, saya tunggu a few buka kamera lah. Okay, on my count. 1, 2, 3, smile. Okay, kejap saya save. Maybe another one. Okay, another one, thumbs up. Okay, 1, 2, 3, smile. Okay, done. Thank you.
Okay, terima kasih semua ya. By the way, sijil nanti kita akan buat dalam masa 1 minggu lah. So kita akan update nama dan hantar sijil kepada semua untuk tugas CPD. Okay, terima kasih sekali lagi kepada semua yang hadir. Okay, Assalamualaikum. Okay, jumpa lagi tahun depan ya.
Terima kasih.
InsyaAllah.
Terima kasih.